Hello everyone and welcome to Evolkai, a machine learning community for machine learning enthusiasts. Now today we will be dealing with K-neighbor classifier. So K-neighbor classifier or K-nearest neighbor are classifiers that are simple and intuitive algorithms used in machine learning to make predictions based on similar examples. Imagine you have a group of friends and you want to predict whether a new person will like a certain type of activity. In KNN Classifier, you look at the friends who are most similar to the new person based on some characteristics. Let's say you consider three characteristics: age, gender, and favorite hobby. Each friend has values for these characteristics. To make a prediction, you choose a value for k, which represents the number of closest friends you want to consider. For example, let's say you choose k equal to 5. Now you find 5 friends who are most similar to the new person in terms of age, gender, and their favorite hobby. These friends become the nearest neighbors. To decide whether the new person will like the activity, you look at the preference of the nearest neighbor. If the majority of them like the activity, you predict the new type will also like it. If the majority does not like the activity, you predict the new person will not like it. The KNN classifier is based on the assumption that similar examples have similar outcomes. By looking at the okay, so let me show you the diagram. Okay, so by looking at the neighbor who are closest in terms of their characteristics, you try to make prediction based on the collective knowledge or behavior of those neighbors. One important thing to note is that the choice of k can influence the prediction. A smaller k value gives more weight to the nearest neighbors, which can make the prediction more sensitive to individual examples. A larger k value considers a broader range of neighbors and can provide more stability, but miss finer distinctions. Okay, so now moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. So and their values will be stored in x, and for the features, and for prediction class the values will be stored in y. X will have all the data that our user will give us as the input, and y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7 is to 3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so we have reached an important part of the presentation. Now we will import a k neighbor classifier from sklearn.neighbors, and will assign it to a classifier variable. Now here we have taken a k value or the n neighbor value as 5, so maximum of 5 neighbor will be considered here. Now we'll fit the classifier with the training data, that is x train and y train, and we will predict the data on the x test and store it in the y pred variable. Now every time the y test here and y pred here will be same, the accuracy will increase. Now this is because we have imported accuracy score from sklearn.matrix, which defines the accuracy based on y test and y pred data. Now we can see that using neighbor classifier is a good practice here, because we have got an accuracy of 95.55 here. Now let's move to the VS Studios to get a practical implementation what we have learned in this slide. Okay, so now we have come to our Visual Studios. So I'll just quickly run all these code snippets. So first we have imported pandas library. Then using the read CSV function, we have read this iris dataset. Now using this info function, we have taken out all the information of the dataset. That what are its columns, if the dataset has null values or not, the data types, and the memory usage. Now we have defined two variables here, that is features and prediction class. So features contains all the input column names, and a prediction class contains all the output column names. To be easier to explain, I'm using input and output, but their original names are features and prediction class only. Now I'll store their values in x and y. For features value will be stored in x, and prediction class value will be stored in y. Now from sklearn.model selection, we will import train test split, and we will split the data into x and y with into training and testing from x and y, and the testing size will be 0.30, that is 30%, and we will check the sizes by printing the x test x train and y test y train. Now from sklearn.neighbors, we will import KN neighbor classifier. The working of KN neighbor classifier I've already explained in my video. Uh, in the previous sections. Now we will fit this model with the training part, and when the model is trained, we will predict the x test value and will store it in the yprint variable. Now using the sklearn, using the metrics from sklearn, we will import accuracy score and use it to calculate the accuracy using ytest and yprint variables. Now for every time they are same or they are similar, the accuracy increases or else accuracy decreases. So this was it for the video. I haven't talked about the hyperparameter which is present in this, that is n neighbors, which is by default 5. So I'll discuss it in my further coming videos. So this was it. Now we will conclude our video. Okay, so in conclusion, the K nearest neighbor or KNN classifier is a straightforward algorithm with applications in various fields, including image recognition, text classification, and recommendation systems. Its simplicity is a key advantage as it is easy to understand and implement. KNN does not require explicit training and can handle multi-class classification problems. It is also robust to noisy data and can adapt to complex decision boundaries. However, KNN has some limitations. It can be computationally expensive, especially for large dataset, as it requires calculating distance between each data point. The choice of the optimal value for k, the number of neighbors, can significantly impact the classifier's performance. KNN is sensitive to the scale of the feature, and therefore feature scaling or normalization may be necessary. Additionally, KNN is not suitable for high dimensional data as the curse of dimensionality can affect its accuracy. So I think this was pretty much it for the video. Now uh, thank you and happy learning.